Good morning, everyone. Today is November 17th, 2022. It's 10 o'clock in the morning, and it's my pleasure to introduce Professor Eirini Ntoutsi to you, who is a professor of computer science. I will go more into the details in a minute of computer science at the University of the Bundeswehr in Munich in Germany. She is here because she has a long track record and an intensive research interest in everything which is related with artificial intelligence. And artificial intelligence, as the lawyers, but possibly also the non-lawyers know, is the subject of one of the many regulatory pieces in the pipeline of the European Commission at the moment. So what I'm sharing here on my screen at the moment is the draft, which is from April 2021. I'm just scrolling it through so that you see that it's quite a heavy text, quite a lot of legislation coming here. It's a draft proposed by the European Commission trying to get their hands on artificial intelligence. And it's a draft that is at the moment quite intensely debated, but still in the making. What you see here now is that the Council on the one hand and some other of the European institutions on the other hand, but not yet the Parliament have published official opinions and input on this draft. We are very much looking forward how this will further develop, but it's one of the many things coming from Brussels at the moment, and it's high time, if you haven't done so yet, to have a closer look into this, because no matter whether you are a lawyer or just a European citizen or a computer scientist, this will have an impact on your daily life, trust me. Professor Ntoutsi, who is here today, is leading the artificial intelligence group at the University of the Bundeswehr, and she's focusing there on the development of intelligent algorithms that learn from data continuously, following the cumulative nature of human learning. So the idea, if I understand it as a layperson well, is to develop AI which is similar in some sense in how, and behaves similarly to, in some sense, how humans learn and what humans are doing when learning. Her research interests include, therefore, continuous learning over non-stationary data and data streams, responsible AI, that's also a buzzword, obviously, from a regulatory perspective, because the idea here is that what is happening in the AI and with the AI should be responsibly undertaken, and there should be some kind of control / liability / responsibility coming with this. And then finally, she's also working in generative AI that is using machines to generate new data and solutions. She came to Munich after a long stay, or a relatively long stay, in Hanover at the L3S, which is the Learning Lab Lower Saxony. That's a rather large research institution in Hanover that is headed by mainly by Professor Wolfgang Neidl. Both of us were active there. This is the reason why we know each other. She also worked at the Faculty of Electrical Engineering at Leibniz University of Hanover. And prior to joining LUH, she was a postdoctoral researcher at the LMU, the Ludwig Maximilians University of Munich, for many years, from 2010 onwards. She has a Greek background. Her basic studies happened in Greece, but a long German education and tradition in educating other people now as her track record. Very, very happy to have you here, Eirini. First question, how is it in Munich, being back in Munich? What is your daily work looking like at the moment?
Hi, Nikolaus. Very nice to see you, and it's great to be able to interact, talk again after I think we met in L3S indeed back in 2016, right? So the earliest should be 2016 when I joined the Leibniz University of Hanover and L3S. So I'm very happy to see you again. And actually, there is a small addition in my career path. So I had also a short stay after the Leibniz University in Berlin, at the Freie University in Berlin. So I had a full professorship on artificial intelligence there for almost 2 years.
Yeah, sorry,
but
I didn't.
No,
sorry.
no problem, because it was short, and And I'm very happy to be back in Munich. So it's like closing a cycle, right? So I came to Munich from Greece in 2010, I think. Yes, it should be that time, and I'm very happy to be back. So I like the south. Munich is a very nice city, and yeah, it feels close to home somehow, right?
Yeah.
And I have been so many years in Germany. I think this does not somehow explain why we don't have this discussion in German. Next time I will try in German.
No, but I think it's fair if both of us don't use their mother tongue.
Exactly.
And both of us talking about things from the other discipline, that makes probably translation even more interesting than normally. So
True.
Yeah,
We'll
quite
be lost in translation.
So one question, Eirini, is, I mean, it's nice to be back in Munich, but I would expect that the Universität der Bundeswehr, which is the military Bundeswehr, the University of the military, has an interest, has a strategic interest in artificial intelligence research when hiring you and opening a position for a full group that you are developing at the moment. So what is the strategic interest behind this?
So I'm part of the Bundeswehr University and of the Research Institute CODE. So CODE is the Research Institute on Cybersecurity and Smart Data, and it's expanding currently. So there are 13 professorships, and I think 11 out of the 13 positions are already filled. And the goal, of course, is to expand also in the direction of artificial intelligence, data science, machine learning, so data-driven learning, because this is a technology that is very important nowadays for everything, right? So you cannot really ignore the fact that we deal with huge amounts of data. We cannot process this data manually. So you need intelligent ways to process the data, to get knowledge from the data. And of course, here come also these responsibility aspects that you mentioned, right? And I think the responsibility or responsible AI should be kind of synonym to AI. Because this technology has such a big effect in our lives. It affects all of us everywhere, at any time. So I think it's really important to consider these responsibility aspects really from the beginning. And by responsibility here, I mean, this is an umbrella term which includes many different aspects. So I'm not working in the full spectrum of responsible AI. I'm mainly working on fairness-aware learning or discrimination-aware learning or anti-discrimination-aware learning. So how can we make AI or machine learning? So I'm mainly working on the data-driven artificial intelligence, which is the modern form of artificial intelligence. So how can we make this technology more fair? So the technology should not discriminate on the basis of protected attributes like gender, race, etc. And of course, what is protected or sensitive, maybe you use a different term here, so I like the term protected, depends really on the application per se, right? So in different applications might be the gender, so it depends on context in general. Context can be the application, can be the spatial context, the temporal context, right? So this is something that from what I learned also changes across time and space. And there is also not a single definition of fairness, right? So in computer science, at least, we have many different definitions of fairness, which come from other disciplines, or law, for example, or social sciences. And some of these definitions, or many of these definitions, have been made operational in the computer science research. So one aspect of this fairness-aware learning is really how to define fairness, so it can be used, let's say, in artificial intelligence or machine learning algorithms. And the second aspect is how can you mitigate the unfairness or bias and discrimination of the models. And I think this is a very important topic and somehow goes back to how these algorithms, how AI, how machine learning algorithms, so I use the terms interchangeably, how they learn. And they learn by using data and algorithms, and the data actually come from all of us theoretically, right? So if you analyze Twitter, for example, have a lot of user-generated content, so whatever biases and opinions, they kind of contribute to this model. So this is one way or a cause of discrimination. So it comes from the data, and of course the interaction between data and algorithms is not always very well understood, right? Because we have very complex models like deep neural networks, and what exactly these models pick from the data, so which features they find important, is not always very clear. So pretty often we don't know actually how the decisions are made. That's why it's very important also to be able to understand how these decisions are made, so the explainability comes into the discussion. And explainability is important not only because end users that use this technology want to understand how a decision is made, whether, for example, they are discriminated or how can they change a decision, but also for us as developers, because we need to be sure that what we develop, I mean, as sure as we can be, right? So there is no 100% certainty, to be honest, but we need really to add these safety checks to be sure that the technology works as planned, right? So to avoid, let's say, these certain failures of the technology, like recognizing a person just based on the background, because in the training set, it happens that all persons, let's say, of a particular gender have, let's say, a pink background. I mean, just as a small example, right? So these are two aspects that we are working on. And I think the responsibility should be somehow part of data science, computer science. So everyone working with data should kind of deal with this technology in a responsible way. And by responsible here, I don't mean necessarily considering fairness and explainability, but I mean, we make so many decisions during this data science, machine learning pipeline, from what data to use, what is our sample, how to pre-process the data. Maybe, for example, we binarize certain attributes. Race, for example, we have only white, black people. So this is already a decision that has an important effect. So we should be aware of these decisions. And sometimes we have to make decisions because we have to proceed somehow, but we should be aware of these decisions, and we should be aware also of the effect of these decisions. And I think this should be really part of the data scientist, let's say, mentality, right? So I have choices, I make choices. What are my choices? What are my decisions? How they affect the outcome? Are these decisions correct? So I think this should be really like a constant, let's say, reflection on what we are doing, because pretty often we just repeat things that we did, right? So we don't really question things that we do on a daily basis. And maybe this is also a cause of problems, right? So I think this is also important.
Yeah, there was already so much in this now, Eirini. I will go
Sorry,
back
Nikolaos,
to the
for not being so.
and then I will try to remember all the questions that popped up in my head when listening to you. So the first question is a very fundamental one. Is it still early enough to develop this in Germany at the moment, or is Germany/Europe so much behind other areas of the world that no matter how ethical or fair or explainable the things that we develop in Europe are, that we will lose track more and more? Are we still early enough? Is there still room for development?
Yes. So first of all, I think European Union, Europe is one of the first actually starting this discussion on responsible AI. And we see also that there are other countries that follow this discussion, right? So I think Europe is actually one of the leaders in this area, which is, of course, very nice. And of course, the growing interest in these aspects is also a good thing. So it's very important that somehow people realize, governments, so they realize that this is an important issue, whether it's too early or too late. I mean, this is a hard question. I think, yes, probably it's... yes, it's a bit late maybe already, because I mean the technology is used everywhere, right, or almost everywhere nowadays, and we have many incidents where the technology is not performing well, right? So I think now we kind of follow a retroactive approach, and maybe you should have been a bit more proactive. The problem is that I think, and I'm curious also what is your opinion, that this is a technology that develops very fast, right? So you cannot keep up with the progress of the technology. And also it's changing very fast, right? So in the beginning, for example, all the machine learning, so traditional machine learning, it's really about, especially supervised machine learning, it's really about predictive performance, right? So fairness, explainability, these were not important, were not considered, right? So the goal was really to build models that can predict correctly. And now we realize that predictive performance in terms of the classes, right? So how well the model predicts the different classes is not the only decisive factor, right? So we want models that, of course, can predict well, but we want models that are also fair if there are humans involved in the training data. We want models that are trustworthy, so maybe we can understand, explain their decisions. We have maybe privacy concerns, right? So it seems that the requirement for machine learning algorithms are growing, right? So it's not only about optimizing predictive performance, it's really about optimizing like a multi-objective space, right? So you have many different objectives and all of them are important. So I think we should, as computer scientists especially, we should definitely move from the traditional optimize for predictive performance to considering also other aspects. And another aspect could be, for example, related to energy, so environmental impact, etc., right? So towards sustainability. So I mean that we should really consider other aspects when developing models, because the complexity of the problems we are dealing with is much bigger, and we need to consider also other aspects. So I think Europe is leading the way in this direction. We have also other initiatives, for example, the AI bill from the US recently. But of course, there are a lot of things that are not clearly defined in this proposal, right? So for me as a computer scientist, I have, for example, a lot of things that need further clarification. And these things are, for example, with respect to what applications should be banned, right? So the European Union has this classification of different risk applications from high risk to low risk, etc. And it's not really clear what is a high risk, what is a low risk. And I think this is something so new applications come over time. So I'm just afraid that maybe it's too late to name something as high risk or low risk, right? So it should respond fast. And I'm not really sure how fast the legal considerations can be the legislation can be. And also, for example, fairness and non-discrimination is one of the key concepts in this in these guidelines, right? But again, what does it mean being fair? There are so many definitions of fairness, right? So it's really unclear what is fair, and I know that the default legal answer is it depends, but this somehow complicates, I think, the work of a computer scientist. So how can we implement, let's say, these different fairness considerations into the algorithms? And with respect to fairness, I have the impression that with artificial intelligence, we have now many different decision-making setups. For example, in this data science, we have pipelines, right? So this means many different components which provide input-output to each other. And of course, there are propagations of biases, discriminations, assumptions, etc. And it's not only about propagation, it's also about amplification. So you have these sequential effects, and we have also maybe these cumulative effects. And I'm not very sure how the legal literature addresses these aspects. So for me, for example, as a computer scientist, this is very important because we have these pipelines where many different components interact with each other, and discrimination, different types of discrimination can take place in these different components, but I'm not really sure how should I combine, let's say, these different aspects of discrimination and what should I mitigate for. And we have an ongoing collaboration with legal experts in this direction in the context of the bias project funded by the Volkswagen Foundation. So we work in this area of multi-discrimination, if you have discrimination with respect to more than one protected attributes. And it seems that as a computer scientist, I can find many different ways to combine, let's say, this aspect, but what makes sense from a legal point of view and what is a good way or a valid way to define discrimination, taking into account this sequentiality and this cumulative effect, it's not always very clear. So I don't know if you have a different opinion. But
No, on the contrary, I think this is I think there are at least two very, very interesting and important points in what you're saying. The first one is the following. When you take a term like fairness, right, or explainability, or responsibility as a goal into the development of a system, it's obviously a question what that means, right? And lawyers, of course, do have a rather long tradition in interpreting abstract terms, in particular such terms, by going back to the fundamentals and explaining fundamental rights in many cases. So a lot of those questions are finally leading to fundamental rights issues. The problem here is this is obviously plenty of interpretation and plenty of different views, also legal views that are very different. And there is no such thing like it's like this or that and end of story if there is no case of the final instance indicating in this or that, under this or that, in this or that facts, this or that is the consequence. This is the only thing which is written in stone. Apart from this, everything is argumentation and gray area. And therefore, I think that the perspective of a computer scientist that the lawyer should tell them how to run the system will not work, because the lawyer doesn't know either, right? So the lawyer can tell you about the principles, and they can tell you it might be that the better arguments lead into this or that direction, but that's it. There is no clear yes and no. And the question that is then going back to the computer scientist is, in how far is this a computer science question, so something which needs to be answered in your own discipline, such as what is an algorithm, right? So what is a fair algorithm? Or is this something that you try to ask other disciplines, such as law or ethics or political sciences? And my perception of this is that in many cases, computer scientists expect other disciplines to get the answer right and to get the answer right. And then in addition, to make things even more complicated, you take this lawyer or that ethicist and this jurisdiction or that book, and it's getting a mass of different perspectives, leading into the second problem, which is the self-recruitment of computer scientists and the self-recruitment of the academic system and also the commercial system, which leads to a situation where the people starting to think about fairness are not necessarily diverse by themselves, right? So there's all kind of biases already in the group of people thinking of this, and it's I would expect it to be very difficult to then find an agreement that is not only covering this subgroup of the population, but the whole population in the world, on what fairness might mean in the development of such a system. And that leads to I would assume, a very, very fundamental ethical dilemma. And then it's quite easy to simply continue with what one has done already for the last 20 or 30 years without thinking too much about changing anything here, right? So it's my first answer to this. And the second answer, and the second question is even more fundamental, which is, if you're talking about data, I mean, there's a principal thing about data, which is that it's always about the past, right? So there's plenty of information about the past. And when it comes to artificial intelligence, we also try to have some kind of impact on what's going to happen in the future. So you take something from the past to develop something, and the outcome should have an impact on the future. And then mixing all together the factors that I had in my first question for an outcome with something which is from the past only, and by definition only, leads to a situation where some people I talk to are rather reluctant whether that would be possible at all to implement something like fairness or responsibility into such a system. In particular, when it comes to the tough questions, such as how to use those things for military purposes, for example. And just as an anecdote to this, interestingly, for many reasons that I don't want to cover here now, but interestingly, the regulation or the draft of the regulation says clearly in Article 2 already that it will not apply for AI systems that are used exclusively for military purposes. You have it here in this part of the text, right? So we are developing something apart from and despite all those issues that I try to cover in my statement here, and still it might be that we are missing, or it might not only be, it is probably the case that we are missing quite some significant developments outside the scope of this legislation.
Yes.
Question to you.
I think I can foresee what your question could be, right? Because of my new affiliation. To be honest, I'm not sure how these issues are handled at the Bundeswehr, right? So I'm employed here as an academic, and I think I have the academic freedom, right? So we are an academic institute. So I cannot answer to this question because I don't know. I think this is something that is super important, of course. And my goal as a professor, as a teacher, I mean, is of course to convey not only the technical challenges and possibilities and abilities of the technology to the students, but also these implications, let's say, and how can we mitigate the risk. I haven't seen any student yet, right? So I start my teaching in January, so I don't know. So I don't have a personal experience, I mean, yet. But one of the lectures that I will offer, and this will be, so the teaching here is organized in trimesters. In the third trimester, which will be after the summer break, I will offer a lecture on responsible AI, because I think these are aspects that everyone should be aware of, and everyone working with data, right? So I think these responsible AI, so working with data properly, let's say, proper evaluation, proper experimentation, reporting on the right things, this should be part of the daily, let's say, ritual of every data scientist, right? So we should really understand what the systems are doing to the extent that we can, right? I'm not saying that we can understand everything, and especially be aware of our decisions and also of decisions that are made for us by all these frameworks that we are using, right? So nowadays, no one or almost no one develops these algorithms from scratch. So many of us use frameworks, and some of these decisions are made by the frameworks. So I can give you a concrete example, which is a bit technical, but I think it's easy to relate to. So let's say you have an algorithm that works with categorical data, right? So, and then you have a data set which has numerical data, and then you use this algorithm. So most probably the framework that you are using will somehow convert or discretize the data, the numerical data, into categories. Whether this is something that you want to have, I don't know. You have to think whether it makes sense in your case. But I mean, this is a decision that's kind of hidden from the developer, from the designer. But it's important to know because it has an effect on the model that you will get, right? So it should be really, I think we need also more, let's say, intelligent humans in this intelligent AI. Yes. Exactly, working with this data. So this is what I can say about my let's say current affiliation, and I'm sorry for.
No, this was not the point that I wanted to make. I mean,
okay.
although this is of course a very interesting point too, but I don't want to ask you a question about the military in particular.
Because I don't know also.
I'm interested. I mean, by the way, this would also be, this would be another addition here, because I would again see that, outside Europe, plenty of things are happening here, and China and the US are probably less reluctant in other legislations to less reluctant in developing things here, and that might also have a strategic impact. But that's not my point here. My point is, I completely understand your point that awareness is an issue here, and that awareness needs to be strengthened. However, although I'm aware, it's still the case that I'm using an algorithm that was developed by somebody else, using some preferences and settings I'm not fully aware of, and it's used by me, being the outcome also of a set of preferences, education, social background, and so on. And if I'm aware of this, I still can't change it. There is no alternative. And then I'm using a data set, which is, again, the outcome of all kinds of decisions taken by someone whom I never met and of whom I don't know too much. Yes. And again, I may know this, but I can't change it. So what is the on top then that I need to do, apart from knowing that those things happen, and how can I change them? And again, is this a question where a computer scientist or a data scientist asks a lawyer then, or an ethicist, or a philosopher, or is this something which needs to be incorporated into computer science?
So if, just to be sure that I got it correctly, right? So you have an algorithm, like a black box, which someone has optimized, or let's say a deep neural network. So you have the algorithm, you can feed the algorithm with a data set, you get an output, but you don't know exactly what the algorithm decides, how the algorithm decides, etc. Right? So you see only the input-output. And then you have a data set which was collected in some way. You don't know exactly how the sample was collected, what assumptions, whatever, right? And then you want to combine these two to make some decision, right?
Yes.
So there is a lot of uncertainty. I would
assume that this is what I would assume to be a typical scenario.
Yes. 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 So this is really a typical scenario, and because now, all these there are a lot of models available, right? So you can find pre-trained models. You can use them, for example, word embeddings, right? And you know that these models, or some of these versions, they have biases, let's say gender biases, and then of course you use it in your hiring application, and no surprise, the output of the system, let's say, is biased with respect to gender, as an example, right? What you can do, I think, you have to kind of understand that the decision that you are making based on a black box that you don't completely understand how it was trained, and what are the assumptions and biases in the training data, and based on a data set which is, again, maybe biased, not biased related to discrimination, but maybe coming, let's say, only from Germany, while you want to make decisions about Europe, right? So just as an example, I think it's clear in this case that if your data set comes from Germany, then the decisions that you can get, especially if this data set was used in the training of the model, then you don't know whether this is something that can be generalized over Europe somehow, right? You train a model in a particular context, you apply it elsewhere, you have to kind of ensure that what you have learned is transferable, right? So you cannot blindly apply it. I don't think you need a lawyer here to verify that. I can tell you as a computer scientist that things that you learn on a particular context might not be transferable directly into another context. So maybe you have to retrain it, or to apply transfer learning, or definitely to check how it performs in the new context, because there are certain assumptions in machine learning. So one assumption, for example, is that the training and the testing set should come from the same distribution, right? So otherwise, you have all these concept trees, right? So the other research area that you mentioned about this continual learning and adaptive learning, right? So you have changes in the data. And this means that if you learn a model on a particular version of the data, and then your testing set, so prediction set, is different, then of course you have to see whether the prediction still makes sense. So we have to take into account such, so during, I think these are maybe responsibility aspects or aspects we should really think about during the deployment. So can I deploy a model in a different setting? I should test how it performs there, right? So I cannot blindly apply it. And also, can I deploy a model that I learned in 2000, let's say 20, to the problem in 2022? I mean, there are so many changes that might happen from 20 to 22, right? So again, this is something I think we need to kind of monitor the performance of these models and react if we realize that something does not work as expected. And this should be like a constant monitoring, right? So you cannot really, because it's not only that the data changed. I mean, maybe there was some error in the training, some biased training set, which you didn't realize, and later on, this is reflected in the performance, so you need to react, right? So you need really to monitor the systems, because many things can go wrong.
Mhm. Mhm.
I'm not sure if this answers your question, but
It does. I mean, it's. I'm thinking a lot about this, because I think this is not really the. I fully understand what you're saying, but I don't think that this is the approach undertaken by this proposal of the AI regulation. Because
yes.
in my reading, that this is very different. It puts different risk categories into the market, and whether something is risky or not is mainly the outcome of what it can be used for. So, for example, you have this. Let me share this with you. This is a list of systems that, according to this proposal, are to be considered as high risk systems. And you see that it's mainly about the scenario where those can be used: biometric identification,
Yes.
critical infrastructure, education, employment, private, and so on, right? It's law enforcement. So it's about where is this going to be used, and if this is something which is sensitive, then it's high risk. This is not what you're telling me here, I think, at the moment, because what you're telling me is that the risk is already in the system, no matter what it is used for, because of those biases. And if that is true, then in my view, the answer to this from a legislation point of view would need to be, we need to invest into people and machines identifying those biases, and we need to make it a very hard legal obligation and or a very interesting legal incentive to monitor those biases, no matter where the system can be used for then later. So it would be a very different approach, right?
So yes, I think it's not like a static decision somehow, right? Is this the right application or not? So I totally agree that some applications, so there are high risk applications, but I mean, I think we need really to constantly monitor these systems and have safety checks to ensure that they work correctly. And correctly is not always related to discrimination. I mean, maybe you have systems that have nothing to do with, human discrimination, like maybe some sensors in a factory, etc. But again, you want to ensure that these systems work correctly. And this cannot be like a static decision, because the data that these systems use, they change, right? So this is just an example of changing data, in this direction of adaptive learning, continual learning. And because there are many assumptions that we make in machine learning, like this stationarity assumption, I mean, you have a model, you train it, you are sure it works as expected, you apply it, and then you apply it again. I think there is no guarantee that in the second application, so let's say next year, or in the second time point, the model will perform correctly, because the testing population might change, or your assumptions about training, testing, stationarity might be different, right? So I think we need a constant somehow supervision of how this technology performs during the deployment. I don't know if this is something that should be regulated, or this should be part of the data scientist, let's say, responsibility, that we need to ensure that our systems work correctly, but I think it's very important to monitor these systems for their performance, because they are used again and again, and many things can go wrong, or many assumptions might not hold after a while. And I'm referring especially to this, streaming data, so non-stationary data, because this is an area we are working on. And I think this is not really covered in the document. And another thing I think that is emphasized in the document is the importance of explanations, right? So explainability. I'm not sure if they call it explainability. Maybe they use a different term. I don't remember now if it's explainability, but I mean, it's one of the key requirements. It's also, they call it explicability, right? One of the 4 principles is explicability. And yes. So this is also very important, but I think another thing that is kind of not well defined here, so very abstract, is what is an explanation and what is a good explanation. And there are many different explanations you can generate. There are a lot of assumptions when I generate explanations using a machine. So let's say these local explainability methods, for example, there are a lot of assumptions. And again, many things can go wrong during this generation process. So the question again is, should we trust the explanations as the only truth if we know that there are a lot of assumptions to generate these explanations, and if we know that there are so many different ways to explain a thing, right? So even as humans, I mean, we can explain things in so many different ways. All of them might be valid. Which one is the best is not very clear. So I think we should treat also these explanations with some uncertainty, let's say, right? So of course, it's a tool that helps us to understand certain things about the model and how the model decides, but it's not the only truth, because there are so many different ways to explain things. I find this also very hard, also from a technical point of view, because it's really hard to evaluate explanations, right? So there are a lot of methods for generating explanations, and then the question is, how do these methods perform? What is a good explanation? And you don't have a ground truth always, which tells you, look, this is what you are trying to find. So usually in these explanations, yes, there are many aspects and many assumptions involved. And one particular type of explanation that I like personally very much, but I understand also let's say the risk and the uncertainty maybe associated with these explanations are the so-called counterfactual explanations. And I like them very much because they give some sort of recommendation. So sometimes we call them actionable. So you can give some insights to the user about what the user can change in order, for example, to get his or her loan application accepted, right? So maybe the counterfactual would be, if you increase your salary by, let's say, 50K, then your loan will be accepted. And yes, the question is whether this is something that is realistic, right? So how much effort it takes to implement, to materialize such a change, and how actionable they really are, right? So again, just to summarize, right? So explanations, I think it's a super important tool, but trusting the explanation as the only truth, and I think it's also not a good idea, because explanations might be also wrong, or might,
Eirini, perhaps coming back to this and the explanation part, or the interaction between the lawyers and the computer scientists in this. So again, coming back to the text, right? So one of the things, and we worked on this already, one of the things that you need to do if you have an high risk AI is that you need to have a proper risk management system. That's one of the very first obligations, right? And when you're reading when you're reading this as a computer scientist, such as I'm quoting now here, section 2 of this Article 9, The risk management shall consist of a continuous iterative process run throughout the entire life cycle of a high-risk AI system, requiring regular systematic updating. That's okay. That's understandable. But now the tricky part starts. It shall comprise the following steps. A, identification and analysis of the known and foreseeable risks associated with each high-risk AI system. I will not go into, this is the first point I make, right? This is something a lawyer can't answer, right? I can't answer what the known and foreseeable risks of any given AI system might be because I don't know anything about the AI system. And I would assume many of the computer scientists or data scientists don't know too much of the risks either. So two questions coming out of this. Who is the right person to do this, right? And where is the interplay between the legal and the AI / data science / computer science contribution to this? And second, who can monitor this? Because at the very end, it will be regulators, and regulators may consist of some computer science experts, but mainly it's lawyers and it's regulators and it's people with a very different background. So is this something that helps you in achieving your goals, or is it something which is not really useful but doesn't do any harm either, or is it, or so it's irrelevant, or is this something which makes things even more complicated?
So first, I think this term of the risk term here is a bit generic, right? So what do you mean by risk? And maybe this could be risk, for example, related to discrimination. So in this case, maybe becomes a bit more concrete. But I think it's not only about discrimination, right? It can be also maybe physical risk. I mean, I'm talking now about embodied AI, maybe. So this is something that needs to be clarified. And also, you are right? So it's not clear here who is involved in this system, right? So what are the actors and who should undertake this establishment, implementation, documentation, maintenance, continuous in the iterative process. I think it's good that they mention the documentation, right? And there are several efforts now to document the models, but also the data. So the discussion that we had before, that's really important to know how the data were collected. So there are different standards or close to standards approaches to really document models, data, so everyone is aware actually about how the data were collected, for which purposes, and what sort of implications, biases, etc., considerations should be considered. I think it's also nice that there is this term continuous and iterative, right? So the knowledge discovery process, so this was the term before the data science hype started, and now, I mean, it's called AI, maybe. But in this knowledge discovery process, or the original term, actually it's an iterative process, right? So the idea is that you start from the data, pre-processing, applying the algorithm, evaluating, etc., and then you have the option to go back at each step and improve, right? So it's an iterative process where at each step you can really go back based on the performance in this step and take corrective action. So I think this is also a good term, the iterative. The continuous, I think it's also a good term in the sense that, as we discussed before, right? So these are systems that are put into the production and they make decisions again and again, right? It's not that it's one step, one point decision, right? So I think it needs also this continuous, let's say, monitoring. Who should do the monitoring? I don't know. I personally, it's not specified. I mean, I personally think that you need both legal experts, at least, and computer scientists, because what the computer scientists can do is that they can easily, or they can identify actually what might be the problem in the system, right? So if I see, for example, that the performance drops in the new instances that arrive, then I can maybe think that maybe it's a problem of this non-stationarity, right? So maybe the testing data have different characteristics than the training. And then I know that I have to update my model, right? So I think it's important to have these two, at least these two together. How these teams will work together, I don't know. I mean, you mentioned in the beginning, right, that, and I had this experience also that in the beginning I was expecting a clear answer from you. Give me definition, I can implement it. I'm happy. I don't need you anymore.
And vice versa. Give me an algorithm and I don't need you anymore.
Yes, and it seems that you need to know a lot about, or quite a lot about how the algorithms work. I need to know also a lot about what to expect from you, what is the problem, right? And of course, I mean, as a computer scientist, I can develop methods to mitigate certain effects, but I need your input, so I need to work together. What sort of skills? Right, so I'm looking for the unicorn, I think now. And what sort of teams, how they would work together, I don't know. I think also this idea of having a person that knows everything, so the unicorn paradigm, I think this is not really, it's very hard, right? Because, I mean, the technology is progressing very fast. The legal, I think, literature also, right? It's, I think, really difficult to have someone that is really up to date with everything. So probably working in teams is the best idea. And I think there has been a lot of discussion about why it's important to work in such multidisciplinary settings and why we cannot solve these problems only as technical problems. How to work together, I mean, I think it's still a challenge, I believe, right? So I don't know what is the best way to work together. I think for me, in my experience, I think what was very nice always in my collaboration with legal experts, but also with philosophers, is that everyone was coming into this discussion, in these meetings, in the project, without feeling that he or she is the only expert, right? So I think everyone somehow had this attitude that we need to to work together. And I think this is the right attitude. How exactly these teams should be built and, where are the responsibilities and boundaries and how to interact, I'm afraid I don't have a good solution yet. And I think it takes also a lot of time to establish this common vocabulary and understanding and appreciating, I think, what everyone is doing, right? So I think appreciation is also very important in the sense that we need all the disciplines, right? If I come with attitude, yes, I can solve this problem I can implement a solution and I don't need you, I think it will never work, right?
One of the outcomes of this debate is, I think, that we also need to think about how to educate people, in particular our students. And just for the legal education, I can tell you that this is not really incorporated into the standard curriculum, right? So the standard curriculum is still learn about the law, don't care about the facts. And it's complicated enough to understand the law. And there is very little interdisciplinary education happening in law. And I would assume that it's not that different in computer science, right?
Yes.
So
So we are mainly focusing on technical skills. I think there is a shift lately, which is not reflected in the curriculum, but there are several offers, let's say, in the direction of responsible AI, and really not related to fairness or discrimination explainability, but really how to work with data in a responsible manner, like documenting, thinking about these assumptions, what sort of data I have, what is the result, does it make sense, right? Because of course, if you run any algorithm with some data set, you will get a result. The question is whether this someone has to interpret the result. So I think this is for us, for computer science, I mean, these data competencies are very important nowadays. And I think, of course, also this multidisciplinary, right, so other considerations for technical solutions beyond, let's say, the traditional performance, right? So legal aspects, ethical aspects, etc. And what I find very promising, and I enjoy very much. I mean, in the lectures, I had such discussions. So my most recent experience with students is from the Freie University in Berlin, that they are really interested in these topics. And I think the reason that they are interested, and the same holds for me, is because they are topics that you can easily understand that affect our lives, right? Maybe it's not me directly, but maybe it's my daughter, my husband, my whatever, right? But it's clear that this technology somehow affects us. So it's important also to make the technology better. And the second one is because they are very hard to solve technical problems. I mean, now we didn't discuss about the technical difficulties, but for example, if you go from single discrimination, so discrimination based on a single attribute, to multi-discrimination, so if you have more than one protected attributes, then you have a couple of challenges for machine learning. One of the challenges, for example, is that you don't have sufficient data for all the different subgroups. Right? So you have, for example, subgroups in the intersection of gender, race, and age, let's say, and some of these subgroups are very sparse, right? So you don't have enough data, which means that the model will never learn them if you don't intervene in some way, right? So I think it's also technically very challenging, and that makes this topic very interesting. So as a person, but also as a technical person, let's say.
Yeah, this leads me back to the question that I had 20 minutes ago. So about the data sets and the given data set and the unknowns about the data set, right? So when you look into Twitter data, I would assume you don't know very much about them, and you don't know very much what is not there, right? And that makes it then very different. If you have then 3 or 4 different categories you need to cluster those data with, it's getting very, very complex, and at the same time very intransparent, right? And on the other hand, the law requires you to follow transparency obligations, and unfortunately, again, they are very abstract, right? Just to share that again with you, and that's my final comment here. For example, this is a definition of what transparency obligations would need to be. High-risk AI systems, it's Article 13, Section 2, for those who want to read it. High-risk AI systems shall be accompanied by instructions for use in an appropriate, whatever that is, appropriate digital format or otherwise that include concise, complete, correct, and clear information that is relevant, acceptable, and comprehensible, right? And I think you could write a PhD thesis about every single word here.
Meaning,
and you try to apply this then to any given really existing data set that is the basis of any of your AI systems, you end up in some kind of a rather complicated situation, right? Yeah, go ahead.
Sorry, Nikolaos, I just wanted to say about the data, because I think this is a very good point, right? So usually when we discuss explainability, we kind of refer to the models, right? Explain a model. But pretty often, actually, it's not only how the model decides, it's also the lack of knowledge about what sort of data the model used for training, right? So for example, let's say in these loan applications, right? So how much of my history the system is using, right? Is the last 6 months, is 12 months? What sort of features? Do they use also information from my social networks? And we had exactly this discussion in a project that we had at the Freie University. So this was about explainability and what sort of information should be shared with the final consumers. And one of the discussions that we had in this group, so I was leading one of the subgroups, one of the important somehow outputs of this discussion was really that pretty often we don't know which of our data, how long the history, what features, what other sources have been used, what sort of data are used for training a system. It's not only about how the system decides, but also about what sort of data the system is using, right? So I think we need also more transparency with respect to the data, especially if we have these, again, temporal applications where the history of the observations is also very important. It's the last month, it's my whole life that matters, right? So how much of my history affects a decision about me. And I think in certain cases, the history is limited, right? So if I recall correctly, there are applications where, for example, in telecommunications, maybe, I think they can store only the most recent history.
Yeah.
I don't know how long this history
and that's
is.
for legal reasons, by the way, again, right? So this is also a very interesting question, because of course, the legal framework has an impact on which data is there, and the legal framework so far was very clear in whatever you have, delete it as quickly as you can if you don't need it anymore, right? So that is striking back in a way now here, right? Because suddenly you end up with a data set which might not be representative because it's simply covering a too short time period, right? So again, that would be a very legal question now, what that means for data protection rules in particular. But I don't see too much of this in the draft act, right? Because, again, probably because
Exactly.
nobody really knows, right? So again, it's already rather difficult to follow the discussion within computer science as a lawyer. And then if the computer scientist tells me we don't know either or not sufficiently either, and I'm starting to think then, okay, there is a fundamental principle in data protection which is active there for 50 years now. Perhaps this is not a sufficient argument that the computer scientist tells me there might be an impact, but I don't know too much about the size of the impact to change the fundamentals, right? So,
yes. So this seems like a problem that somehow is created by this particular law, but of course affects whatever data you get, because we are bounded to this recent window. And I think another aspect that is not very clear is, and it's also very important, it's about the up-to-date version of the data, right? So pretty often we have information here and there, like in my case, right? So you described my CV and a bit of information was missing, and I think this is pretty often the
again.
case.
I know it because I remember you leaving Hanover. I just skipped it.
Yes,
I'm
yes,
sorry again.
yes.
Yeah.
No. This was not my point. But I mean, my point was that information is not always up to date, and we make decisions on information that is not always up to date, or part of it is up to date, right? So we have different veracity also with respect to the recency of the information, and this is also not. This affects the decision, obviously, but again, I think this is not very clear how to validate the information, how to ensure that the information is up to date, and who is responsible for that. Should I check, for example, what information my bank has about me, or is this the bank should do it? So there are a lot of important issues which affect the data that are collected, which of course affects the algorithm, affect the decisions. Yes.
Yeah. So the good news, to wrap this up, perhaps the good news is there's plenty of work. The bad news is things aren't easy, right? It's tough work that is ahead of us, and the legal answer, whatever it might look like, is just one of the many that we need, right?
Yes. So I think there is definitely a lot of work, and I think we should. It's sometimes hard to assess whether there is a real progress made. I'm not sure, to be honest, and this is something that, so it should really aim for real progress. Yes.
Yeah, and academic debate is certain. If there is any progress, academic debate is certainly one of the requirements we will need for that. And I'm grateful, and I'm positive that this academic debate will continue. And Eirini, I would like to close this, if I may, if there's not an important point that you still want to add. Is there any?
No. I think we covered many things. So
not everything, of course, but quite some, I think. Yeah.
Yes.
So if there's nothing to add for the moment, let me close this by really thanking you most warmly, but also by explaining that I would really appreciate if we could continue with this debate, the two of us as individuals, but also our disciplines, because I think that the academics driving their disciplines in their fields here need to talk more with each other than they often tend to do at the moment. And let's hope that this is going to happen, because it's an important task for Europe and also for the Europeans living here. Thank you.
I totally agree, and I find this interacting with other disciplines or legal experts in this case very enriching, right? So I feel like I'm kind of opening a bit my matrix,
Yeah.
not very much, but I think we definitely need to consider other. It's a necessity, right? So it's not an option. It's a necessity, I think.
Yeah.
And I'm looking forward to. I mean, now I think we are closer, right? So
yeah, slowly.
so
Next time, actually, we could. I mean, just one more remark on this: we could make things even more complicated, because probably we would need an ethicist, we would need a philosopher, a psychologist, and somebody having a background about the economy running all this, also in this debate, right? So it's not just the law and computer science, right? So, and just like before, then complexity explodes, right?
Yes, that would be really nice, actually. I think also psychologists. Really, I think disciplines, because I think computer scientists and legal experts and philosophers, I think this is the most common, let's say, combination in the area of responsible AI. But there are definitely other disciplines involved, and maybe just opening the box more, increase the complexity, but I mean, maybe becomes more realistic.
Yeah, hopefully. So thank you so much for the moment. Thank you to you who listened to this. I do appreciate your attention. I hope that we stay in touch. I hope that you remain interested. And in particular, I hope that all of us stay healthy, or become as healthy as possible, as quickly as possible. Have a wonderful day, and all the best. Bye-bye. Thank you.
Bye-bye.